Hello everyone, welcome to Yatri IS, Road Student. And this is our vertical that deals with answer writing only. And so far we have covered GS Paper 1 Geography of 2014 and 15. And now we will take up 2013 GS Paper 1 Geography questions. And this is your syllabus. And today's question is asking about continental drift theory. Continental drift theory was proposed by Alfred Wegener in the start of 20th century. And the way we are going to move ahead with the question is, first we will provide an introduction to the demand of the question, after which I'll provide you a map for your deeper understanding, mapping. And after that, I'll cite you the evidence that proves the continental drift theory. And after the evidence, we will see what India has to do as far as this is concerned. And towards the end, we will also take a very insightful and relevant conclusion. So without waiting any further, let's begin.
Please rotate your phone to portrait.
So the continental drift theory, first you will explain what it is. It was proposed by Alfred Wegener in 1912. And it states that all the present day continents were once united into a supercontinent, Pangaea. Which was surrounded by one water body, that is Panthalassa. And later on, the continent drifted apart to their present positions due to tectonic processes. So that is a very relevant introduction you could provide to your answer. And after providing this, you should also mention, earlier it was one mass body which was called Pangaea, and the water body was Panthalassa. Then with tectonic processes, this was divided into two land masses, which was separately called Laurasia and Gondwana land. And India is part of this Gondwana land. And with this tectonic processes, you see present day continents. So after providing this introduction to your answer, start mentioning the evidence. The very first evidence you would mention is that is jigsaw fit of continents. How do you validate this point? You would validate this point by making a map. At this point, jigsaw fits in this region of Africa. Then you would mention that continental shelf is matching. The continental shelf between two different continents, it is matching with other continents. You see similar continental shelf. Then you see geological continuity. In this, you see similar mountain chains across continents. Mountains across continents. And you could cite the example. You mentioned that Appalachian Mountain of America are linked to Caledonian Mountain of Europe. Then you would mention similar rock sequences. In this, you find identical rocks, their age, their composition, both identical across all continents. Then you mention you also find coal deposits in Antarctica, which indicates former tropical climate. Then you would mention paleoclimatic evidence as well. Like you see desert deposits, coral reefs, they both indicate continents occupied different latitudes. So this is one more reason. Then you can also mention Mesosaurus fossils. What is this? This is fossils of fresh water reptiles found in South America and Africa that are identical. You also see gold placer deposits in South America and Africa. That shows that these two land bodies were one mass body. After this, you could also mention paleomagnetic evidence or seafloor spreading and plate tectonics. These theories indicate and confirm continental movement. You need to prove these points because when Alfred Wegener proposed this continental drift theory, he failed to explain the driving force behind this continental spread. So during that time, this theory was not validated as ardently as it is now proved. So these evidence prove the hypothesis proposed by Alfred Wegener. Now you mentioned what India has been doing in this aspect. We have National Center for Polar and Ocean Research in Goa. And what it does, it studies Gondwana geology. We also have Seabed 2030 initiative, in which we are mapping the ocean floor for more understanding of plate tectonics. So after mentioning this, towards the end of your answer, you would mention, although Alfred Wegener, this is Alfred Wegener, but you need to write it in full. Although Alfred Wegener failed to explain the mechanism behind continental movement, drift, his visionary hypothesis revolutionized earth sciences. And you should also mention that modern plate tectonics theory aided by paleomagnetism and seafloor spreading validates most of his hypotheses, and this has transformed continental drift theory from a speculative idea into the foundation of geomorphology. And this explains so many features, geophysical features like earthquakes, volcanoes, mountain building, continental evolution. So that is the importance of the theory of Alfred Wegener. So that is how you are going to attempt this question. Thank you. Hello everyone. Welcome to Yatri Guidance, Roads to Rank. And this is our initiative that deals with answer writing only. And this is your syllabus of Geography GS Paper 1. And today's question is asking about naming of tropical cyclones. How these tropical cyclones are named. So the way we are going to move forward with our answer writing is, first, we will provide a very insightful introduction. We will connect our introduction with the demand of the question. Then we will cite the reasons. Because in this question, you do not have much to provide. So you will start your answer by providing the reasons and how tropical cyclones are named. Then surely we will see something related to current affairs, the naming of certain tropical cyclones. And after that, we will see something related to India. Then we will see certain initiatives of UN. And towards the end of your answer, we will conclude it with a very relevant and insightful conclusion. So let's begin.
Please rotate your phone to portrait.
Start your answer by saying that tropical cyclones are among the world's most destructive weather systems. And to ensure the efficient forecasting and disaster communication, we have to name those weather patterns, weather systems, so that awareness can be spread. So you will mention in your introduction to ensure for this, you see World Meteorological Organization has institutionalized a scientific system of naming tropical cyclones across different oceans. So this can be a very relevant introduction to your answer. And you could also mention that cyclone names are not assigned to its intensity, its order of occurrence. However, but it is assigned from a pre-approved list prepared by WM. So that is going to be a very relevant your answer. You could also make a map to show that different water bodies have different name. This is you can see that tropical cyclones in this region are called typhoons. You see such weather systems are called hurricanes in this region. You see around Australia, those weather systems are called willy willy, and in Indian Oceans, they are called cyclones. So you could mention this. You will address the demand of the question. How these cyclones are named. So very first reason you would cite is, with global coordination, names of such weather systems are selected under World Meteorological Organization. Then you would mention ocean basin-wise system. That means that separate committees maintain list for different ocean basins. All the ocean basins of the entire world have their committees which maintain their separate list. Then you would mention the importance of RSMCs, which is Regional Specialized Meteorological Center. So you have you also have RSMC New Delhi as well, which prepares a list for oceans in Indian Ocean. And these specialized centers issue names for cyclones within their jurisdiction. So this is one such reason. Then you would mention all the member countries submit their separate list of names. To their specialized centers. For example, India has given names like Gati, Tej. Bangladesh has given name like Remal. Pakistan has given names like Gulab. So all the countries give their separate names and they all are included in the list for one ocean basin. After this, you would mention that sequential naming is done from the list irrespective of country affected. So this is also done. Then you would mention that a tropical disturbance receives a name after reaching the prescribed intensity, because a lot of weather systems develop in ocean bodies, but not all weather patterns are given names. So there is a minimum prescribed intensity for cyclones, which is called cyclonic storm stage. And for Indian Ocean, this is more than 63 km per hour. If cyclone intensity is more than this, then you would name that weather pattern. After this, you would mention names should be short, culturally acceptable, easy to communicate. So such names are also preferred. Then you would mention offensive and controversial names are avoided. After this, you would mention when you see a very highly destructive cyclone, and because of that a lot of casualty has taken place, the name of such cyclones are permanently retired. This is also practiced. Then you would also mention that naming of cyclones enhances public awareness and reduce confusion. So this is also practiced. So that is how a naming of cyclone is done. And after this, you could also mention certain examples from current affairs, like we have seen Amphan cyclone in Indian Ocean. We have seen in Tokte cyclone in Arabian Sea. We have recently seen Remal cyclone as well. So all this demonstrate the functioning of regional naming system. And after this, you would mention what India has to do as far as this is concerned. In India, we have a mission called Mission Mosam, which was launched in 2024. And since then, we are trying to modernize our weather forecasting. So we are moving ahead with this mission. And you also have an initiative by UN that is called Early Warning for All initiative. And this promotes universal early warning coverage by 2027. Could provide value addition to your answer by mentioning these two initiatives. And towards the end of your answer, you would mention a scientific and internationally coordinated cyclone naming system has transformed disaster communication by making warnings clear, memorable, and actionable. So you could provide this conclusion, or you could value addition your conclusion with this, that coupled with India's advances under Mission Mosam, early warnings for all initiative by UNWMO, by UN World Meteorological Organization, effective naming has become an integral component of saving lives. And building climate resilient societies. So that is how you could provide a very insightful and address the demand of the question and provide such a conclusion to your answer. Thank you.
Hello everyone, welcome to Yatri IS, and this is our initiative that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today's question is asking about formation of urban heat islands. What are the causes for the formation of urban heat islands? So the way we are going to move ahead is, first, I will provide you a very relevant introduction, focusing on the demand of the question. Then I'll provide you certain data for your deeper understanding and enrichment. Then I will provide you a diagram, which are always welcome in a geography question. And then I will provide you the main body, reasons. After providing you reasons, I'll provide you what India is doing as far as this topic is concerned. And towards the end of your answer, I will provide you a very relevant, insightful conclusion. So without waiting any further, let's begin.
Please rotate your phone to portrait.
The very first thing that you need to mention is the definition of urban heat island. What are urban heat islands? It is the phenomenon where urban areas remain significantly warmer than surrounding rural areas. Warmer than surrounding rural areas. And this can happen due to various reasons, due to human-induced modification. Modifications of land surface and atmospheric processes. So this is the definition of urban heat island. Now let me provide you certain data as well. Data is always for enrichment of your mind and deeper understanding. Like urban areas, they are commonly around 1 to 7 degrees Celsius by rural areas. And this extent is more during night. And then you have a data by UN that says that currently you have around 56% world's population living in urban areas. And this is expected to reach nearly 68% by 2050. So that shows the importance of urban areas. And if this phenomena of urban heat island continues, it will be a very big problem as a whole. We need to address it. And you could mention that green cover or trees, they can lower surrounding temperature by 2 to 8 degrees Celsius through their shades and process of evapotranspiration as well. So you could use this data in your answer as well. So now let me provide you a brief understanding of the causes. So you could attribute this major chunk for built up surfaces. Then you could mention this 25% for loss of green cover in urban bodies. Then you could mention anthropogenic heat as well. Then you could mention transport and industry. And others. So this is a brief outlook of the factors that is causing urban heat island phenomena. So now let's move ahead with our beginning. And before I begin, let me provide you a diagram as well, like for your deeper understanding. Like if this is a rural area where you see green belt sufficiently, and this is your sun. So when the heat comes, this is a rural setup, and with the process of evapotranspiration, taking place more, you see less temperature. You also see cooling through its shade, and as a result, you see less temperature in rural setup. Then, if you see these are long buildings in urban cities, when the sun provides its heat, the heat is trapped between these buildings. This is an urban setup, and you see concrete and use of asphalt in urban areas, which store heat and as a result you see increase in temperature. And when temperature is increased in urban bodies, this difference is called urban heat island. So you could use this diagram to show what urban heat islands actually are. You could also mention that urban heat islands are primarily a surface energy balance problem. And not merely a temperature problem. What does this mean? That you see imbalance between incoming solar radiation, UC reflected energy, UC stored heat, anthropogenic heat, evapotranspiration. So imbalance between all these factors transforms cities into persistent heat reservoirs. So this is a perfect start for answer, and you could use these points for a short introduction. You don't need to mention all of this. So this is for your more and clear understanding as well. So now let's move forward to the main body, that is reasons. The very first reason you would mention is replacement of vegetation. Replacement by concrete, asphalt, and this leads to loss of evapotranspiration, and with loss of evapotranspiration you see surface temperature rising. Then you would mention low albedo materials are used. In cities such as asphalt and dark roofs, they absorb more heat, and in the night when this stored heat is released, you see temperature rise. This is also happening. Then you would mention concrete heat storage, because buildings possess high thermal capacity, which intensify night urban heat island. After this, you would mention anthropogenic heat that we are causing. Like vehicular pollution, vehicular emissions, more and more use of ACs, you see industrial emissions as well. So this is also increasing the temperature of urban bodies. After this, you would mention urban canyon effect. Urban canyon effect, what does it mean? It means that tall buildings, they trap radiations and reduce long wave heat escape. Because UC rays reach Earth in short waves, and when they strike land, the land absorbs heat, and during night, in the form of long waves, it releases it. But when you have tall buildings in urban setup, this release is trapped here, which increases temperature in urban areas. After this, you would mention reduced wind circulation as well. That is, dense construction in urban bodies blocks ventilation, and this results in stagnation of heat. After this, we would mention encroachment of water bodies as well. When you see declining marine ecology, you see reduction in evaporative cooling, and this leads to rising temperature. After this, you would mention rapid urbanization. With rapid urbanization, you see expansion of impervious surfaces which absorb more heat, leading to urban heat island formation. After this, we would mention population density is one reason, because with more population, you see increase in energy demand. With increase in energy demand, you see anthropogenic heat emissions rising. This is also one more reason. After this, you mention air pollution as well, because aerosols in the atmosphere trap outgoing terrestrial radiations. And this enhances warming. After this, you would also mention air conditioning feedback as well. This is a edge point because most of the students do not mention this. What does this air conditioning feedback mean? When you see more and more usage of ACs, and what does AC do? AC cool your indoors but expel hot air outside. So this increases temperature. So this is also done. Then you mention limited green cover in urban bodies. You see less parks, urban forests are missing. Then you mention climate change as well. Because with rising temperature due to climate change, this amplifies urban heat island intensity. So these are the reasons which you could mention in your main body. And now let's see what India has to offer as far as urban heat island is concerned. And we have smart city mission. In smart city mission, we are promoting cool roofs, green infrastructure, etc. We also have Amrut 2.0 that encourages urban green spaces and water body rejuvenation as well. Then you also have National Mission for Sustainable Habitat, which is promoting or addressing increasing urban temperature. And you can also mention a network called C40 Cities Network, which promotes heat resilient cities globally. And towards the end of your answer, you would mention that urban heat islands are an unintended consequence of rapid urbanization. Hence, we need to adapt nature-based solutions. We need to adapt cool materials. We need to adapt blue-green infrastructure and climate sensitive urban planning. And all of this can transform cities from heat traps into climate resilient habitats. And this supports Sustainable Development Goal 11, that is sustainable cities and communities. So you could end your answer with conclusion like this. Thank you.
Hello everyone, welcome to UPSC, and this is a vertical that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today's question is asking about temperature inversion and its effects on weather and habitats. So we have to cover all this area. So the way we are going to move forward is, first I'll provide you a very relevant introduction. After that, I'll provide you a flow chart for your deeper understanding. And after providing you the flow chart, I'll provide you diagram representation, which is always a very good idea as far as geography questions are concerned. After that, I'll provide you effects. The question has specifically asked effects on two things, that is weather and inhabitants. So we will cover both. And after providing you, and this is the main body, we will delve our maximum time in this. And after that, I'll provide you what India has to do as far as temperature inversion and its impacts are concerned. And towards the end of the answer, I'll provide you a very relevant and insightful conclusion. So without waiting any further, let's begin.
Please rotate your phone to portrait.
So in the starting, you would start the answer by defining what temperature inversion is. You need to provide a very simple definition for temperature inversion. And you could write, it is a meteorological condition in which air temperature increases with altitude instead of decreasing, because the normal phenomena which is seen as you increase your altitude, the temperature normally decreases. That is normal lapse rate. But temperature inversion is the opposite of that. And this creates stable atmosphere, preventing vertical mixing of air. So this is a very sorted introduction you could provide by defining temperature inversion. Or for value addition, you could cite that temperature inversion acts as atmospheric lid, suppressing the atmosphere boundary layer. This term itself is very important and students do not mention this. So this is very important. And this layer, this atmospheric lid, traps pollutants, moisture, and cold air near surface. And this makes temperature inversion a key reason behind Delhi's winter smog. You must have seen that in the months of December, January, Delhi experiences egregious level of pollution. And this is the main reason behind it. You also see aviation disruption as well, and cold wave persistent as well. So this is something you could mention in your introduction, and you could use this for your deeper understanding. Now I'll provide you a diagrammatic representation and a flow chart afterwards. So let me tell you, the phenomena of normal lapse rate is like when the surface is warm, air rises, and if you see the surface temperature is 25 degrees Celsius, after 1 kilometer you will see a dip of minus 6.5 degree. That is, it will be 18.5 degrees Celsius after 1 kilometer. So this is normal. This is condition of normal lapse rate, in which temperature decreases with increase in altitude. But temperature inversion is opposite of this. When the surface temperature is, let's say, 10 degrees Celsius, and as you move upward, you see increase in temperature. That is, if there is a 20 degrees Celsius, you see this is a condition of temperature inversion. So this diagrammatic representation is very important for deeper understanding. Now let's see the flow chart. When surface is cool, dense cool air is settled near ground, and when this cool layer is near the surface, you see a layer of warm air above this cool air. You see this layer of warm air here. This is cool air and this is warm air, and here you see, and this gap between these two layers act as lid, and this is a condition of temperature inversion. And due to temperature inversion, you see stability in atmosphere. And when the atmosphere is stable, you see a variety of things, like you will see fog, persistent fog. When fog is mixed with smoke, you also see smoke. Then you see frost formation during this time. You see poor air quality because vertical air is not mixing and the pollution in the air stays where they are generated. So this is the flow chart. And now let's move towards the main body, that is effects. First, we will see effects on weather. What are the effects of temperature inversion on weather? The very first is, as we saw, stable atmosphere is created. Stable atmospheric conditions prevail due to temperature inversion because it suppresses convection, which is vertical mix, and it also suppresses cloud development. After this, you would mention temperature inversion leads to dense fog due to condensation of trapped moisture. And with dense fog, you will also see persistent smog. Because when pollution is mixed with fog, it is called smog. Because pollutants remain near the ground. After this, you would also see visibility is affected, is reduced, and this disrupts road, rail, air traffic. So you see disruption in all sorts of transportation. After this, you would mention, due to temperature inversion, cold wave is intensified because cold air remains trapped in the valleys. This is a phenomena that occurs majorly in mountain valleys, but the phenomena is exactly the same. The cold air is trapped near the surface. Then you also see frost occurrence, and this damages agricultural crops. Let me explain this as well. Like if this is a mountain valley, the cold air temperature is less here and temperature is more here, and this is the lid that is created, and due to this you see a lot of frost, and conditions are very inhabitable in the valleys of mountain. After this, you would mention probability of rainfall is very less due to stable atmosphere. Temperature inversion suppresses cloud development due to inhibition of vertical cloud growth. After this, you would see valley inversions. Valley inversion is another name for temperature inversion. but it is happening in mountain valleys. So these are the effects of temperature inversion on weather. Now let's see effects of temperature inversion on inhabitants. You will continue your points from here. Due to temperature inversion, you see a rise in respiratory diseases. Such like asthma, bronchitis, etc. Then you will also see that high exposure to particulate matter 2.5, and this increases cardiovascular risk. So this is also the impact of temperature inversion on our health. Then you would mention transportation accidents. Every year you see clips of cars colliding with each other on very foggy highways. So that is the impact due to poor visibility. Then you would mention we also face crop losses and economic loss. After that, you would mention productivity of agricultural crops is reduced. Because the cold stress by temperature inversion and poor air suppresses the quality of agriculture, the quality of crop. This is the impact. After this, you would mention greater health burden. Temperature inversion, and due to that heavy smoke, exposure to particulate matter, this has really heavy burden on specifically elderlies, children, outdoor workers who are exposed to the atmosphere almost all the day. They are actually bearing the brunt and cost of temperature inversion on ground. And then you will also mention higher heating demand, because with low temperature conditions you see household energy consumption increasing. So these are the impacts of temperature inversion on weather and on inhabitants. Now let's see what India has to offer as far as this phenomena is concerned. We have CAQM, first of all, that is Commission for Air Quality Management. And what it does, it activates graded response action plan, GRAP, during inversion episodes. You must have seen in the news that during the month of December and January, the Delhi government often resort to strict GRAP measures, even odd schemes. So that is due to temperature inversion. Then you also have NCAP, which is National Clean Air Program, which aims to reduce particulate pollution. So you can mention these two initiatives by India, and towards the end of your answer, you will cite that temperature inversion is a natural atmospheric phenomenon with significant socio-economic and environmental consequences. And with increasing urbanization and climate variability, accurate forecasting, cleaner emissions, integrated air quality management are essential to minimize the impacts of temperature inversion while improving public health and climate resilience. So these are the pointers which you could use to frame a short and crisp conclusion, which will give you maximum results. Thank you.
Hello everyone, welcome to the 3 Roads to Rank. And this is our vertical that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today's question is asking about hot deserts and why they are concentrated majorly between a certain latitude and also towards the western sides of the continent. The way we are going to move forward is, first, I will provide you a very relevant introduction. After that, I'll also provide you flowchart to make you understand what is happening. After flowchart, I'll provide you mapping and diagrammatic representation. After that, we will see the main body, that is reasons. We will see reasons for both. Why hot deserts are majorly found between this latitude and towards the western side. So we will see reasons for both. After this, we will see what India is doing as far as desert protection is concerned. And towards the end of your answer, I will provide you a very insightful conclusion. So without waiting any further, let's begin.
Please rotate your phone to portrait.
In the starting, you would mention that location of hot deserts is the result of subtropical high pressure zone plus cold ocean current as well. So you could say the result of subtropical high pressure and cold ocean current coupling. Because neither latitude alone nor cold current alone can create such major deserts. Therefore, their combined interaction produces hyper arid conditions, which is the best condition for desert formation. So let's see certain examples as well. But before we see the example, let's see a flowchart. See, the equator faces intense heating at equator, and due to that you see rise in the air rises upwards, and when air rises upward, where does it go? It moves towards pole. When the air is moving towards pole, it subsides at between 20 to 30 degree latitude, north and south. And after this subduction, a high pressure subtropical zone is created. And when the air subsides and creating this high pressure zone, the air by that time gets dry and the atmospheric conditions are stable as well. And with this stability and dry air conditions, you see no rain, no cloud formation. And when this condition is coupled with cold current in the region, you see temperature inversion taking place. And when temperature inversion takes place, you see drop in evaporation. And when this situation also presents offshore trade winds, then the condition becomes ripe for the formation of hot deserts. So that is how a hot desert is made. So this is the flow chart. Now let's see how diagrammatic representation and the example. This is a rough map of world, and you see 20-degree around here to 30-degree around here, and you see desert formations here. This is the Saharan desert, this is the Thar desert, this is the Arabian desert, you have here Mozov desert. Apart from these deserts, you also have Atacama desert, you see here Nabib desert, Kalahari desert. You see a great Victorian desert in Australia, and the western side of Australia has many deserts as well. You see desert in towards this region as well. So let me also point out certain ocean currents as well. You see Humboldt current here, California current here, cold currents. These are cold currents. And after this representation, let me show you so let's assume this is the globe and this is equator, 0 degree. This is Tropic of Cancer and this is Tropic of Capricorn. So you see that intense heating takes place around the equator and the low pressure zone is created. And when intense heating takes place, air rises in the air. After reaching certain height, it deflects. It deflects in both the directions. And when the conditions are ripe, it subsides and a high pressure subtropical zone is created here. This zone is created high pressure subtropical zone. And you also see westerlies in this latitude and easterlies in this latitude. Due to this convergence of these trade winds, you see a dynamic process and air rises again. And after reaching certain height, it diverges and subsides. This is pole. So this is the representation of wind system that is happening around our globe, and this is called Ferrel cell. This is called Hadley cell. This is called polar cell. So now let's see the main body, that is regions. Regions for formation of deserts between 20 degree to 30 degree. Now, so let's see. The very first reason is descending limb of Hadley cell. When air descends, it becomes warm and dry. And this dry air inhibit rainfall. And dry conditions prevail in the region, leading to formation of hot deserts. Then you see subtropical high pressure belt. In this high pressure zone region, persistent anticyclonic conditions prevail, which suppress convection and cloud formation. Then you see adiabatic heating. When air descends, it warms in the journey, and the descending air warms at nearly 10 degrees Celsius per kilometer, which is called dry adiabatic lapse rate, and this reduces relative humidity. Then you would mention clear sky conditions. With clear sky conditions, you see increase in solar insolation, which further produce extreme daytime temperature, reason for hot deserts. Then you mention stable atmosphere, and the reason for stable atmosphere is temperature inversion, and temperature inversion restricts vertical mixing and precipitation. So these are the reasons why hot deserts are between this particular latitude. Now let's see reasons why they are formed on western side. The very first reason is the presence of cold ocean currents, which prevail dry conditions. For example, you have Canary current leading to the formation of Sahara Desert. Then you have California current. Then you also have Beagle current. These cold ocean currents cool the lower air, which reduce evaporation. When evaporation does not takes place, cloud formation will be restricted, and that itself will inhibit rainfall. And due to that, such conditions will prevail where desert formation will take place. Then you will mention temperature inversion, because with temperature inversion, cool air remains below warm air, and with this, cloud development is prevented. After this, you would mention a very important point, that is offshore trade winds. Northeastern trade winds blow from land and towards sea, and these winds carry very little moisture with them, and towards the western parts, when they reach, they do not have enough moisture so that precipitation can take place. Then you would mention coastal fog, but no rain, because moisture condenses into fog rather than rainfall. And you also have examples like Atacama and Namib Desert, which are also called fog deserts as well. After this, you would mention very important point, that is continentality. And because of this, interior parts of the continent remain dry and far from the marine moisture, and due to that, hot deserts are formed. You also have a rain shadow effect,
For example, in the South America, there is Andes mountain here, and behind its back you see Atacama Desert. So when the air with moisture strikes these mountains, rainfall takes place in this region, and this is the rain shadow zone where desert formation has taken place. After this, you could mention a term called PET, which is very high, that is potential evapotranspiration. It means that evaporation is more than precipitation. So all these reasons combined lead to the formation of such hot deserts. Now let's see what India has to offer as far as desert formation is concerned. We have NAP, that is National Action Program, which combats desertification. Then we have Green India Mission as well, which improves resilience in arid areas. And India has also hosted COP14 in 2019 and continues implementing LDN. What is this? This is very important. This is land degradation neutrality targets. So this is very important. You should always mention this. And towards the end of your answer, you would mention that concentration of major hot deserts between 20 to 30 degree latitude and on western margins reflects the combined influence of the reasons that we stated, such as cold ocean current, subtropical high pressure belt, continentality, and in the era of climate change, sustainable land management, ecosystem restoration, and international cooperation through UNCCD, LDN targets are essential to prevent further desertification and enhance resilience in arid ecosystems. So this is your conclusion. Thank you. Hello everyone. Welcome to Yatri IS, Roads to Rank. And this is our vertical that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today's question is asking about why landslides are so frequent in Himalayas as compared to Western Ghats. So we are going to see variety of reasons for this particular weather phenomenon. And the way we are going to move ahead with our answer writing is, first I'll tell you pointers for a good introduction. Then I'll do a comparison for your deeper understanding of the topic. Comparison between Himalayas and Western Ghats. After the comparison, I'll show you a flow chart This is again for your understanding. And then we will jump to the main body, that is causes. We will cite all sort of causes why landslides are more frequent in Himalayas as compared to Western Ghats. After telling you the causes, I will tell you what India is doing to avoid such disasters. And if at global level there is something, we would mention that as well. And after that, towards the end, we will cite a very relevant and inclusive conclusion. So without waiting any further, let's begin.
Please rotate your phone to portrait.
So initially, let's describe what a landslide actually is. It is the downward movement of rocks, debris, soil. So this is a very basic definition of landslide. You could also mention Geological Survey of India, which says that nearly 12.6% of India's land area is prone to landslides. And of course, Himalayan region accounting for the majority of this percentage because of its fragile geological setting. Now let's compare Himalayas and Western Ghats. See, Himalayan mountain range is called young fold mountain as well, because they have come up because of the folding created between two plates, and it is still continuing. That is why they are very young. On the other side, Western Ghats are ancient residual mountains. So they are very old mountain systems. Because they are young and fold, they have active tectonics. But on the other side, Western Ghats have stable peninsular sheathing. Himalayas experiences frequent earthquakes. On the other side, seismicity is very low in Western Ghats. Himalayas have weak sedimentary rocks, while Western Ghats have hard basaltic rocks. And all these reasons make Himalayas geomorphologically young, tectonically active, and seismically dynamic. On the other hand, these factors make Western Ghats geomorphologically mature and tectonically stable. So you could clearly have a understanding why Himalayan region faces more frequent landslides. So after this flow comparison, now let's see the causes. There are so many causes. For example, we have geological factors. Such as in geological factors, we see, let's call this A. We see Himalayans being young fold mountains. They have weak rock formation, and due to this faces comparatively more landslides. Then you would mention Himalayan region have active plate collision, which results in continuous convergence of plates that creates instability. Then high seismicity, because frequent earthquakes triggers slope failures, and as a result you see landslides. After this, you see presence of major faults in Himalayan region, such as MCT, MBT, HFT, and all these major faults, they weaken slope structures. Then you have highly fractured rocks in Himalayan system, which makes landslides more frequent in Himalayas. Then you have geomorphological factors, like Himalayas have very steep slopes. This increases the impact of gravitational force. Then you have rapid river incision. Himalayan region has numerous number of perennial rivers which undercuts slopes, making the Himalayan region very fragile. Then you have glacial erosion, which leaves unstable moraines and debris. Then you have high relief difference, which causes rapid mass wasting. After this, let's see climatic factors. Intense monsoonal rainfall is one reason, which saturates soil and reduces its strength and makes the slope very fragile. Then you have frequent instances of cloudburst in Himalayan region, and due to this, sudden slope failures are seen. Then you also have snow melting, which increases water pressure, and due to that we have seen instances of landslides as well. And at the end, we would see anthropogenic factors. Very first is infrastructure development in Himalayan ecosystem, like road cutting, like tunnel construction, and this infrastructure destabilized slopes of Himalayan region. Then you have deforestation as the main cause of making Himalayan ecosystem fragile, and it reduces root binding, thereby making ecosystem very fragile. Then you have unplanned urbanization, and of course tourism, which is rapidly increasing in Himalayan region, and this increases load on slope as well as culture, resources, and everything of the Himalayan region. And we could also mention hydropower projects, and blasting also weakens hill slopes. And due to all these reasons, you see landslides more frequent and visible in Himalayan region as compared to Western Ghats. And now let's see what India has to say about this. First of all, let us see certain current affairs. Every year during monsoon season, we see flash floods in Arunachal Pradesh, and we have already seen flash floods and the impact of flash floods in Arunachal Pradesh, where the casualties have gone beyond 1,000 figures, which is very concerning. Every year we see landslides in Wayanad, Kerala, where extreme rainfall can also trigger landslides. Now let's see what India has. We have NDMA, which is National Landslide Risk Management. And what it does, it focuses on hazard zonation and early warning system. This body makes sure the region is categorized in different zones, describing its vulnerability and also a possible warning system as well. Then we also have national landslide susceptibility mapping, which identifies vulnerable regions. And at global level, we have early warnings for all initiatives by 2027 by World Meteorological Organization. We also have Kyoto landslide commitments 2020. So these are also certain initiatives that encourages global cooperation. And towards the end of your answer, you would mention that the greater frequency of landslides in Himalayan region is primarily due to their young geology, active tectonics, steep relief, intense climate forces. These are the regions that we have already covered. So this is what we have already covered, and you would mention as a value point that with climate change, extreme rainfall events, scientific land use planning, ecosystem restoration, hazard mapping, technologically driven early warning system. All these are essential for building resilient mountain ecosystems. So this is a very relevant conclusion for your answer. Thank you. Hello everyone, welcome to Yatri IAS, Tours to Rank. And this is our vertical that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today we are going to talk about why rivers of Western Ghats do not form deltas. So this is the question, and we have to cite reasons for it. So the way we are going to move forward is, first I'll tell you a very relevant introduction, and after introduction I'll do a comparison for your deeper understanding. Comparison between eastern coast and western coast. After that, I'll tell you certain examples of west flowing rivers and east flowing rivers, like that. And after that, we will move to the main body, that is reasons. We will cite multiple reasons. After citing reasons, we will also see what India is doing as far as this question is concerned. And towards the end of your answer, we will cite a very insightful and relevant conclusion. So without waiting any further, let's begin.
Please rotate your phone to portrait.
So initially, you would mention that a delta is a signature of deposition, whereas the rivers of the Western Ghats are signatures of erosion. Because, and why? Because of their geomorphic and hydrological characteristics. And these geomorphic and hydrological characteristics favor estuaries instead of deltas. So that is how you will provide a relevance to your introduction and connect it with what is being asked in the question. After providing this, for your deeper understanding, let me provide you a comparison between western coast and eastern coast. What is the difference between these two as far as features are concerned? So here I'll mention the features and then I'll mention the difference between these two. First, let's see how is the coastal plain. Western coast has narrow coastal plain, but eastern coast has broad coastal plain. Western coast has short river length. On the other side, eastern coast has long river lengths. Western coast has steep gradient, while eastern coast have gentle gradient. Sediment load in western coast is low, but high in eastern coast. Tidal action is very strong in western coast, but comparatively weak in eastern coast. And all these reasons make sure that western coast have estuaries, river mouth development, and all these reasons make sure that east flowing rivers have deltas. So this is for your deeper understanding. Now let's see certain examples. If see this is an Indian map. East flowing rivers, west flowing rivers, and you see here the western parts. So we will see certain examples like Narmada, Tapi, Mandovi, Periyar, Zirari. And east flowing rivers are Ganga, Brahmaputra, Mahanadi, Godavari, Krishna, Kaveri. So the general observation is that these rivers form estuaries and these rivers form deltas. And we have to explain why. So now let's see the main body, that is reasons. The very first river in the Western Ghat region travels very short distances, and due to this you have insufficient, and this is insufficient for large sedimentation. So this is one reason. Then you see that Western Ghats rise abruptly near the coast, and due to this rivers possess high velocity, and when rivers have high velocity this causes vertical erosion instead of sedimentation, rather than deposition. And when deposition does not take place, estuaries are formed instead of deltas. After this, you would mention that western coastal plains are narrow, and because of the narrow space, you see very little space for delta expansion. Then you would mention that rivers in Western Ghats have high erosive power, which transfers sediments directly into deep sea instead of the deposition towards the mouth of the river. Then you would mention Arabian Sea, which is towards the Western Ghat, has steeper continental shelf. And when the continental shelf of Arabian Sea is deeper, the sediments which are anyway carried by the river, they got directly offshore. Sediments are carried offshore instead of accumulation. Then you would mention strong tidal action in the Arabian Sea. And as a result of this, tides remove deposited sediments. After this, you would also mention in the towards the Western Ghat, you see estuary formation instead of delta formation. And what is this? This is nothing but river mouths become drowned valleys, which are called estuaries. Then you would mention resistant peninsular block of Western Ghat. And as a result, rivers flow through hard basaltic rocks and they do not wither easily. And as a result, they have less sedimentation. Then you would also mention heavy monsoonal but seasonal flow towards the Western Ghat rivers. And all these weather patterns, they flush sediments directly into the sea instead of accumulation towards the coast. Then you would also mention absence of large meanders because short rivers do not develop extreme floodplains, and as a result, lateral deposition is very less. After this, you would also mention tectonic stability because western margins is an ancient passive continental margin. This is something that students do not mention, and pointers like this provide you a different edge. And as a result, no significant basin subsidence is seen that favors delta formation. And if you want to sum up all these points in one point, you can mention that marine energy is more than river or fluvial energy. That means that marine erosion exceeds river deposition. And as a result, estuaries dominate in the rivers of Western Ghats. So these are the pointers you could mention in your answer. And now let's see what India is doing as far as this question is concerned. We have integrated coastal zone management. This conserves India's coast and estuaries. We also have a program called MISHTI, that is Mangrove Initiative for shoreline habitats and tangible incomes. And this also protects estuaries and coastal ecosystems. And we could also mention that UN has dedicated this decade as decade of ecosystem restoration and declared it as ocean decade. And towards the end of your answer, you would mention the absence of deltas along the Western Ghats reflects the dominance of marine processes over fluvial deposition. And all these factors that we have discussed, they favor estuary formation instead of delta formation. And this makes India's western coastline geomorphologically distinct from the delta-rich eastern coast. And you could also mention this value addition and the understanding this contrast is crucial for coastal management, blue economy initiatives, and climate resilient planning. That is how you could answer this question. Thank you. Hello everyone, welcome to Yatri IAS, Roads to Rank, and this is our vertical that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today's question is asking to discuss the ongoing visible trend of new sugar mills shifting towards southern states. So what is the reason behind this trend? That is what we are going to discuss. First, we will provide a very relevant introduction to our answer, fulfilling the demand of the question. Then I'll provide you chart representation for your deeper understanding and enrichment of the topic. And then I'll provide you the main body, that is reasons. This is the most important part. And after that, we will see what India is doing as far as this topic is concerned. And towards the end of your answer, we will provide a very insightful conclusion. So without waiting any further, let's move ahead.
Please rotate your phone to portrait.
So you could start your answer by writing what is being asked in the question, like India's sugar industry is witnessing a gradual shift, the trend which has been asked in the question, from the traditional so-called sugar bowl, that is Maharashtra and Uttar Pradesh, towards the tropical southern states. So you could provide this could be a starting, but you also need to mention certain edge points in your introduction, like, and the shift is not merely geographical, but from a subsidy driven sugar economy to an efficiency driven integrated bioeconomy. So this provides some weight to your introduction. And after this, let's see some chart representation. Let's call this southern states. This is North India. There are certain favorable factors which are found in southern India, such as we will mention one by one, like higher recovery rate of sugarcane, then long crushing season, more export potential, better ethanol blending prospects. So these are the factors that make southern states very important as far as this trend is visible. However, you also see very large sugarcane area in the North India as well. You also see huge domestic market in North as well. And this common section can be called, and the common factors between North and South is sugar demand, government subsidies, and increasing farmer income. So this was for your deeper understanding. Now let's move towards the main body, that is reasons. And the very first reason is higher sugar recovery in southern states. And why is this? Because of the tropical climate that prevails in southern states. And the tropical climate enables 11 to 12% recovery as compared to 9 to 10% recovery in North India. So this is very important, because for this you need to see the geography of India, that and Tropic of Cancer passes from here, and you see this is equator and this is Tropic of Cancer, and the region between this has tropical climate that favors that ongoing visible trend. So now let's move forward to the next point, that is southern states have longer crushing period. Because southern states enjoys 220 to 230 crushing days as compared to 140 to 160 crushing days in North India. So this is also a reason for the shift that is visible. After this, you would mention, due to the climatic favorable factors, you see high productivity in southern states. And we have seen examples of Tamil Nadu and Karnataka with their record production more than average production of India. So this is also one reason. After this, we could also mention better quality of cane. And what is the reason behind better quality? Of course, the climatic factors, such as uniform temperature that prevails in southern states, sufficient rainfall, and due to these reasons, sucrose accumulation improves. After this, you could also mention availability of irrigation, large and big river basins of Krishna, Godavari, Kaveri support assured irrigation. So this is also a reason. After this, you also see less impact of frost damage, unlike UP, where frost every year destroys cane production. Then you could mention government support with their ethanol blending program, which is more favorable in southern states because of integrated mills. Integrated sugar mills in South. Then you could also mention ease of mechanization because larger land holdings can facilitate mechanized harvesting, which itself improves the productivity. Then you could mention better transportation infrastructure in the South. Ports aid export can be done. Then private companies are more and more investing in these sugar mills in southern states. Then you could mention climate resilience as well, because southern varieties of sugar are relatively better adapted to the changing climate conditions. After this, you could also mention diversification into bioenergy. We have huge prospect in this area as well, because mills can produce ethanol, mills can produce biofertilizer, mills can produce green electricity, mills can also produce compressed biogas as well. So these are the reasons why you see a shift in the trend. But you also need to mention, however, this trend is not absolute. Trend is not absolute. And why are we saying this? Because Maharashtra still remains one of the India's largest sugar producer. This trend is not absolute because Uttar Pradesh still continues to lead in sugar production due to extensive sugarcane cultivation in Uttar Pradesh. This trend is also not absolute because of water scarcity concerns in states like Tamil Nadu, Karnataka, and due to this, indiscriminate expansion of sugarcane is limited. And this trend is also not absolute because of environmental concerns as well. Because groundwater depletion is a huge impact of sugarcane production, and this can be seen in India at a huge concerning rate. So this you have to mention. After this, we will see what India is doing as far as this is concerned. First of all, we are running a program called ethanol blending program. And with this, India has advanced, made a lot of progress towards 20% ethanol blending. So this you could mention. You need to keep yourself away from the current and the prevalent geopolitics around ethanol blending, because whenever you have to write in your answers, you cannot be anti-government, and you have to write the programs in which India is and the government is progressing with their schemes. So you have to mention this. Then you could mention that we also have a national biofuel policy. That encourages ethanol production from sugarcane juice and molasses. So you could mention these programs, what India is doing. And towards the end of your answer, you would mention in your conclusion, thus, because of the points that we have already discussed, thus, there is a discernible trend of establishing technologically advanced sugar mills in southern India. You could also show a map of southern India to show this. However, sustainable expansion must balance economic gains with water security, climate resilience, and regional equity. So this you could mention in your conclusion. However, as always, I will provide you certain edge points as well, such as the future of India's sugar industry lies not in producing more sugar, but in transforming sugar mills into integrated bio refineries producing sugar, ethanol, green hydrogen, compressed biogas, bioplastics, and renewable electricity as well. And you could mention then all this aligns with circular economy and energy transition, making southern states attractive investment destinations. So this is a value addition you could provide and use these pointers in your conclusion. Thank you.
Welcome to Yatri IS, Roads to Rank. And this is a vertical that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today's question is asking about cotton textile industries in India and what are the factors for its decentralized structure. So we have to delve in this area. So the way we are going to move forward is, first, I'll provide you a very relevant introduction, fulfilling the demand of the question. Then I'll provide you certain data which you can use for deeper understanding and topic enrichment. And then I'll provide you the main body, that is reasons. And students have said that you provide a lot of pointers. And the reason behind providing you a lot of pointers is, first of all, the competitiveness of the exam has increased so much that you need to mention relevant points beyond what is normal and what is the average. And apart from that as well, if I provide you 20 pointers from the start till the conclusion, at least I am assuming that you may be recalling at least 10 to 12 points out of 20 on that particular topic. So that is the reason why I provide so many pointers. So I suggest you watch the video very carefully and utter involvement for better retention and recall. So after reasons, I will provide you what India is doing as far as this question is concerned. And after that, I'll provide you a very insightful conclusion. So let's begin.
Please rotate your phone to portrait.
In the introduction, you could mention the cotton textile industries is India's largest agro-based industry, which is characterized by power looms, MSME sector, mill sector, and cotton textile industry follows distributed manufacturing model. So this is a very relevant point, resulting in highly decentralized production structure. So this is your introduction for this question. You must mention the
same and exact words of the question to provide it more relevancy. Now, let me provide you certain data like share of cotton textile industry in GDP is nearly 2%. Share of cotton textile industry in manufacturing output is 12%. And share of cotton textile industry in merchandise export is nearly 9%. All right, you could mention, this is for your deeper understanding, and you must mention that share of cotton textile industry in employment generation is huge by citing that nearly 45 million people are directly employed and a gigantic 60 million people are indirectly employed with cotton and textile industry. So this was for your deeper understanding. Now we will provide you reasons. The very first reason is wide cultivation of cotton, because in India this belt produces cotton. Then you would mention India has a very large domestic market, and because of large domestic market we have diverse consumer preferences which promote localized production. Then you could also mention low capital requirement, as in power loom units require much lower investment than composite mills. Then you could mention growth of MSMEs. With growth of MSMEs, majority of weaving and processing units belong to MSME sector. Then you could also mention traditional heritage. What does it mean? India has historic weaving centers such as Banaras, Kanchipuram. You must have heard those Kanchipuram saris. Bhagalpur. And this contributes in decentralized production. Then you could mention the sector offers flexible production. Like small units can quickly adapt to changing fashion and export demand. After this sector offers an opportunity for regional entrepreneurship. Like there are certain communities in Gujarat, Maharashtra, Tamil Nadu that promotes clusters. What type of clusters? That is our next point. Cluster development. With the help of textile parks, industrial clusters, we have seen huge development of clusters. After this, you could mention government support, which is quintessential for development of this sector. You could cite certain examples like PLI schemes, are offered PM Mitra parks. Then you could also mention export orientation, because cotton and textile industry cater to niche international markets. Then you could also mention this sector also has a big subcontracting network. Big and large brands outsource weaving, stitching, etc. to numerous small enterprises. You must have seen very high-end expensive brands of Europe. They outsource production unit from India, Bangladesh, Southeast Asian nations. So that's how this sector works. Then you could also mention employment generation. Employment generation. And you could cite the data that we have provided in the starting. Because decentralized structure of cotton and textile industry maximizes rural and semi-urban employment. So you could cite these pointers in your answer. And now let's see what India has to offer as far as this sector is concerned. We have PM Mitra Parks, which is an integrated textile value chains. We have National Technical Textile Mission as well, that encourages modernization and diversification in production of cotton and textile industry. So after mentioning this, towards the conclusion, we would mention the highly decentralized cotton and textile industry combines employment, regional balance, export competitiveness, and with schemes like PM Mitra scheme, digital value chains, India can strengthen its position as a global textile hub while ensuring inclusive industrial growth. So you could mention these pointers in your conclusion. You could also mention value addition, like we can follow 5F vision. And what is this? This is farm the fiber using the fabric for the fashion, fulfilling the foreign demand. So that is how you could answer this question. Thank you. Welcome to Yatri Guidance, Roads to Right. And this is our vertical that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today we will be talking about atomic energy and how it can help in the backdrop of scarcity of fossil fuels. Then we also have to discuss about the availability of raw material as far as atomic energy is concerned. So this is going to be our today's topic. The way we are going to move ahead is, first, I'll provide you a very relevant quote which you can cite in your answer. And starting your answer with a quote gives you an immense edge compared to other students. After that, I'll provide you a very relevant introduction expressing the demand of the question. And after that, I'll provide you certain data for your deeper understanding and enrichment of the topic. After the data, we will talk about the main body, that is availability. And we have to talk about both availability in India and the world. So this is the main body. And after that, we will see what India is doing as far as harnessing this energy and this sector. And towards the end of your answer, we will cite a very insightful conclusion. So without waiting any further, let's begin.
Please rotate your phone to portrait.
So, quote is, energy security is the foundation of national security. And this is a quote by one and only Dr. Homi J. Bhaga. So you could cite such a quote in your answer. Now, we will provide a very relevant introduction, such as with India's commitment to net zero by 2070, atomic energy has become a strategic pillar of energy transition. So this could be your introduction, and you could value addition this by writing, however, the availability and geographical distribution of nuclear fuel minerals determine the long-term sustainability of nuclear power. This could be your introduction for this question. Then you will cite certain data. You could mention that India's share in global uranium is scanty 2% only, but our share in global thorium is 0.25%, that is nearly 25%, which has a huge potential. Then you should mention that we have a vision for India's nuclear capacity by generating 100 gigawatt of electricity by 2047 through nuclear technology. You could mention this. So now we will jump towards the main body and talk about availability. First, in India, uranium availability in India limit our potential and nuclear fuel security as well, because we have very less deposits of nuclear minerals and we largely depend on imports. So that is the availability. Then this imported uranium strengthens our critical mineral diplomacy, which reduce supply risk. After this, however small are the reserves of uranium in India, but there are certain places that have major deposits, such as we have deposits in Jharkhand, in Jaduguda, we have deposits in Tumalapalle, in Andhra Pradesh, and this is very important because it is among the world's largest deposits. That is very important region in Andhra Pradesh. Then we also have deposits in Telangana. We have deposits of uranium in Rajasthan as well, in Karnataka, Meghalaya. So we have deposits of uranium, however scanty. Then we would mention we can focus on thorium economy because, as we discussed, we have nearly 25% of global reserves of thorium in India, and this presents a strategic edge to India, and it can provide long-term energy security advantage. We have monazite-rich sands in Karnataka, in Tamil Nadu, in Odisha, in Andhra Pradesh as well, which can be harnessed for thorium economy. Then we also have a closed fuel cycle that translates into India's three-stage nuclear program. And this converts limited uranium into plutonium and ultimately utilizes the abundant thorium reserves, ensuring resource sustainability. Then you would mention we are focusing on fast breeder technology. And recently we have succeeded by achieving criticality at Kalpakkam nuclear power plant. Prototype fast breeder reactor at Kalpakkam nuclear power plant reaches criticality, which will enhances its utility, enhances its fuel utilization and reduce dependence on uranium. Then you would mention we also have other strategic nuclear minerals as well, which are needed, which are essential for reactor component, such as zirconium, beryllium, rare earth minerals. So that is how you will show the availability as far as India is concerned. Now we will see availability in the world. We will mention uranium availability is geographically concentrated. In few countries only, like largest share of nuclear availability and production is done by Kazakhstan, that produces 43% of uranium. Then you have Canada, which also produces at vast scale. Then you have Namibia. Australia has the largest recoverable uranium reserves. However, it produces only 8%. And this you could mention as others. So that is how uranium availability is geographically concentrated in very few countries, creating resource geopolitics. Then you would mention availability of thorium as well. India has the largest reserves of thorium, nearly 25%. Then is Australia. Brazil also has vast reserves of thorium. And we have USA, Norway, and others. So this is the availability of thorium. Then you will mention recycling and closed fuel cycle, because we have countries like France that recycles spent fuel, that improves fuel efficiency and reduce uranium demand as well. So that is how technology has been developed in certain countries. Then you would mention that there are certain technologies which are emerging in nuclear sector as well. Such as small modular reactors, generation 4 reactors. These technologies are also coming into the picture that improves fuel utilization and reuse waste produced in the process. That is the availability. Now let's see what India is doing as far as this question is concerned. We have mission critical mineral that aims to secure strategic minerals supply chain. Then we also have civil nuclear agreement partnerships with countries like Canada, Australia, Kazakhstan, and many more, which strengthens our critical mineral diplomacy. And you should mention that recently we have passed an act which is called Shanti Act 2026 that welcomes private sector and their investment in nuclear power generation. Shanti stands for sustainable harnessing and advancement of nuclear energy for transforming India. So that is how what you could mention as far as India is concerned. And towards the end of your answer, we will mention that India's comparative advantage lies not in uranium, but in its vast thorium reserves. And by leveraging the 3-stage nuclear program and using technologies such as closed fuel cycle, critical mineral diplomacy, advanced technology, India can transform its resource constraints into long-term energy security as well as strategic autonomy. This is how you could end your answer. And let me also provide you a quote to end your answer as well. The future of atomic energy lies not merely in power generation, but in ensuring sustainable development with energy security. So you could mention this quote as well. And I provide you enough number of pointers for your answer for the topic concerned. And I hope that you may be able to recall at least 10 to 12 points out of 20, 25, 30 pointers that I provide. And using these pointers, you could answer this question. Thank you. Welcome to Yatri IS, Roads to Rank. And this is a vertical that deals with answer writing only. And this is your syllabus for GS Paper 1 Geography. And today's question is asking about India's substantial reserves of shale gas and shale oil, and how India can tap this potential to ensure energy sovereignty. So the way we are going to address this question is, first, I'll provide you a quote. Then I'll provide you a very relevant introduction addressing the demand of the question. Then I'll provide you certain data for your deeper understanding. After providing you data, we will move towards the main body, that is availability of shale gas and the importance of shale gas in India. And after this, we also have to delve in the area of issues. Critical evaluation has to be done for the same as well. After this, we will see what India is doing as far as exploration of shale gas and shale oil is concerned. And towards the end, we will see a very relevant and insightful conclusion. So without waiting any further, let's begin.
Please rotate your phone to portrait.
You could cite energy security is the backbone of economic security. This is a quote by International Energy Agency. So you could cite certain such type of quotes. Now let's bring out the introduction with India importing 85% of its crude oil and nearly 50% of its natural gas, unconventional hydrocarbons such as shale gas and shale oil offer an opportunity for energy sovereignty. However, their exploration is constrained by a lot of factors such as water energy nexus, ESG concerns, resource nationalism, and geographical complexity, etc. So we will be doing this critical evaluation towards the main body. Now let's see certain data. According to EIA estimate, India has nearly 96 trillion cubic feet of recoverable shale gas. So that is a huge potential that India has. So you need to keep this data in your mind. Now we will see the importance of shale gas in India. We will see its importance and availability. First is, it is important for our energy sovereignty. Because Indian shale resources are capable of supplementing energy needs and reduce import dependence. So that is how shale gas is important. Then we will mention geological potential. And in this point, you should cite the data of EIA estimates that India has nearly 96 trillion cubic feet of recoverable shale gas. And where is it available? It is available in major sedimentary basins. Major sedimentary basins of Cambay, Gujarat, Krishna Godavari Basin, Kaveri Basin, Damodar Valley, also available in Assam, Arakan Basin. So all these regions have huge potential as far as exploration of shale is important. Then you would also mention policy support by Indian government. That government permits exploration of unconventional hydrocarbons. So that is the importance of support given by government, and we have programs like HELP and OALP, which we will be discussing later onwards. Then you could also mention strategic importance. Because exploration of shale supports energy transition by replacing coal with cleaner natural gas. It's a bridge fuel. And you could also mention certain explorative missions of India, that in the Camp Bay, Gujarat, ONGC is conducting pilot drilling programs. In Assam Arakam Basin, oil, that is Oil India Limited, is exploring eastern sedimentary basins as well. So you could mention this as well. Now we have to mention the issues and the critical aspect of this. The very first issue that arises is water energy nexus. What does this mean? This means the technology which are used in the extraction of shale gas, like hydraulic fracturing, which is also called fracking. This technology requires enormous quantities of water. And this creates conflict in water-stressed regions. So this is a very big concern. Then you would mention ESG concerns. This means environmental, social, and governance concerns. Because there are certain risks which are associated with its exploration, like risk of groundwater contamination due to chemicals used during fracking. We have risk of methane leakage during exploration, and methane, which is a greenhouse emission gas. So these are the issues which are connected with this. Then you would mention geological complexity. Because Indian shale formations are deeply and highly complex for exploration, which makes exploration very difficult. Then you would mention high cost of extraction in India. And this discourages economics of scale. And makes extraction commercially very less attractive. After this, you could also mention very good point, that is resource nationalism. Because land acquisition challenges, local community resistance delay such type of projects. Then you would mention regulatory uncertainty. With multiple environmental clearances and overlapping jurisdictions, these projects are often delayed. Then you would mention infrastructure deficit in India with limited pipeline infrastructure, storage facilities, and processing infrastructure. All these things hinder commercial viability. Then you can also mention limited technical expertise, because India is dependent on foreign drilling technologies, which raises operational costs. Then you could also mention seismic risks, because with fracking and exploration of shale gas, fracking can induce minor earthquakes. Raising public safety concerns. And you could also mention climate commitments. Exploring for hydrocarbons and fossil fuels is against the climate commitments that India has done. Expanding fossil fuel extraction in conflict with net zero 27 target. This is the critical evaluation that this question demands. Now let's see what India has to offer as far as this question is concerned. We have hydrocarbon exploration and licensing policy, that is HELP. We also have open acreage licensing program, and both of these programs encourages exploration. India also has national green hydrogen mission that shifts long-term focus towards cleaner fuels. And towards the end of your answer, you will mention shale, oil and gas can act as a strategic bridge fuel for India's energy security. But indiscriminate extraction may compromise environmental sustainability. Hence, a balanced strategy will ensure that energy sovereignty complements climate responsibility. So that is how you could provide a very insightful conclusion. The best energy policy balances affordability, security, and sustainability. Quote by IEA. So that is how you could provide a very insightful answer to the question. I provide you multiple pointers, and I hope that you may recall and retain at least 10 to 15 pointers out of these on a particular topic. Thank you.